Hello students, welcome back to my YouTube channel Chemphilia. Today I'm going to start a new section called Concept Booster. In this segment I will discuss topics or concepts which are very important but many of you give it a miss. Now questions are asked from these topics, so it's very important to know these topics in detail and also know the tricks to save valuable time while solving these problems in exams. So without wasting any time, let's start the first video of Concept Booster series. And today I'm going to discuss the relation between different concentration terms. Okay, so first I'm starting with uh, relation between, just a minute, relation between molarity, which is expressed by capital M, and normality, which is expressed in capital N. Okay, so relation between molarity and normality. Now see, the relation is very simple. Normality, that is capital N, is equal to molarity, that is capital M, multiplied by NF. Now what is NF? NF is called N factor. Okay, now remember, depending on the nature of substance you have taken, it can be acid or base or salt, the N factor is different. Clear? So here let us write the substance, and here let us see what is the N factor. Now remember, for acids the N factor is basicity. Basicity means the number of H plus ions it releases. Then for bases the N factor is acidity. Acidity means the number of OH minus it releases, or you can say number of H plus ions with which a base molecule reacts. Then another type of substance is salt. Now for salts, remember the N factor is number of cations into its charge. Okay, for salts it's number of cations into its charge, right? Or you can write number of anions into its charge as well, that will give you the same N factor. Then for oxidizing agents, or we can say oxidants, or reductants, that is reducing agents, and where oxidants or reductants are used in, obviously in redox reactions. So in redox reactions, remember the N factor is the number of electrons, just a minute, the number of electrons transferred. Transferred means the number of electrons gained or the number of electrons lost. Clear? So I think you have, uh, you have come to know what is N factor for different classes of substances. Clear? So the next relation is relation between relation between molarity, that is capital M, and mass percentage. Mass percentage. Okay. So This is the next topic, molarity and mass percentage relation. Now let us see how is the relation. Now let us consider, let x be the mass percentage, x be the mass percentage of a solution. Clear? And let us consider some more. M be the molarity of the solution. Clear? And let us consider M2 is the molecular weight, or you can say molecular mass of the solute, and small d is the density of the solution in gram per ml. Clear? Now what is the mass percentage? X. Now mass percentage X means in 100 gram of solution, X gram of solute is present. So 100 gram of solution contains X gram of solute, right? Now what is the volume of the solution? Now volume of the solution is mass divided by density. Now what is the mass of the solution? It's 100. And what is the density of the solution? It's d. And since the unit of density is gram per ml, so obviously the volume unit will be ml. Clear? And another thing, just a minute, sorry, number of moles of solute is equal to, you know what is the formula of number of moles? It's mass by molecular weight. So what is the mass of the solute? It's x gram, and molecular weight of the solute is m2. Clear? So basically the volume of the solution is 100 by d, and the number of moles of solute is x by m2. So we can say 100 by d ml of solution contains x by m2 moles of solute. Clear? So volume we have got, number of moles we have got. So molarity is, you know, that number of moles of solute, number of moles of solute upon volume of solution, just a minute, in ml multiplied by 1000. So what is the number of moles? It's x upon m2. What is the volume of solution in ml? It's 100 by d into 1000. So it's x by m2 into d by 100 into 1000, right? Now 1010 is cancelled, so the relation is x into d into it's just a minute, another zero will be cancelled, so x into d into 10 divided by m2. So finally the relation is molarity is equals to x into d into 10 divided by m2, and you know which one is what. Means x is the mass percentage of the solution, d is the density in gram per ml, m2 is the molecular weight of the solute, and capital M is the molarity. So we can keep it within a box. So this is the relation between molarity and mass percentage. Clear? So I hope you have understood this relation. And now we are going to the next next concept, next topic, that is relation between molarity, that is capital M, and molality, that is small m. So what is the relation between molarity and molality? This is very, very important, I'm telling you. So look at this relation. Now say capital M, uh, say capital M be the molarity of a solution. Yeah. So molarity of the solution means 1000 ml of solution contains m moles of solute. Clear? Now d is the density of solution in gram per ml. So therefore mass of the solution, now you know that mass is equal to what? Volume into density. So what is the volume? 1000. And what is the density? D. So it's 1000 d gram. Here that is the mass of the solution, and mass of solute. Now mass of solute means we can say number of moles multiplied by just a minute molecular weight. So number of moles is m, molecular weight is m2. So m2 is the mass of solute. Therefore mass of solvent, so mass of solvent is basically 1000 d minus mm2. 1000 d is the mass of the solution, mm2 is the mass of solute, the mass of solvent is 1000 d minus mm2. Clear? So what is molality? Now molality, that is small m, is number of moles of solute divided by mass of solvent in gram into 1000. So what is the number of moles of solute? It's capital M. mass of solvent is 1000 D minus MM2 multiplied by 1000. Clear? So we can say molality is equal to molarity into 1000 divided by 1000 D minus MM2. So this is the relation between molality and molarity. Clear? So I hope you have understood how the relation between molarity and molality is coming out. Now let us moving on to the next part. The next relation is relation between relation between molarity, just a minute, and mole fraction. Relation between molarity and mole fraction. Now here let N1 and N2 be the number of moles of solvent and solute respectively. Clear? So N1 be the number of moles of solvent, N2 be the number of moles of solute. And moreover, say N1 plus N2 is equal to 1. So mole fraction of solvent, that is X1, is equal to N1 by N1 plus N2, that is N1 by 1, that is N1. Clear? So X1 is equal to N1. Similarly, X2 is equal to what? N2. Clear? So mass of solvent is equal to its number of moles, that is N1, into its molecular weight, that is M1. So here remember, M1 is the molecular weight of solvent. Clear? And M2 is the molecular weight of solute. Clear? So here the mass of solvent is N1 M1. Now in place of N1 we may write X1, so it's X1 M1. Similarly, mass of solute is equal to its number of moles, that is N2, into its molecular mass or molecular weight, that is M2. Now instead of N2 we may write X2, so it becomes X2 M2. Therefore mass of solution is equal to mass of solute plus mass of solvent, or we can say it's X1 M1 plus X2 M2. Clear? So we have got the mass of solution. Now volume of just a minute, and say D is equal to density of solution. Obviously the unit is gram per ml. Therefore volume of solution is equal to mass by density. Now mass is x1 m1 plus x2 m2 divided by its density. Sorry, its density is not 10, it's D. So mass divided by density is the volume of solution, and that is x1 m1 plus x2 m2 upon D. So what is the molarity? So molarity, that is capital M, is equal to number of moles of solute, that is N2, divided by volume of solution in ml. So this is the volume of solution, x1 m1 plus x2 m2 divided by D into 1000. So now you know that in place of N2 we may write x2. So it's x2 into D into 1000 divided by x1 m1 plus x2 m2. Clear? So therefore we can say that molarity is nothing but x2 into D into 1000 divided by x1 m1 plus x2 m2. So this is the relation. Clear? So I hope you have understood the relation, and then let us come to the last relation of this video. Just a minute. And now the next relation is relation between molality, that is small m, and mole fraction. Okay, so let us see the relation between molality and mole fraction. See the main uh, parts, that is the symbols that we have used in the previous relation, those same symbols will be used in this relation too. Clear? So here we are writing small m is equal to molality, x2 is equal to mole, just a minute, mole fraction of solute, and n1 is number of moles of solvent, n2 is equal to number of moles of solute. Say n1 plus n2 is equal to 1, therefore x2 is equal to n2 by n1 plus n2, that is n2 by 1, that is equal to n2. So x2 is equal to n2. Clear? And m1 is equal to molecular weight of solvent, clear, and x1 is equal to n1. From this relation we are getting this. Okay, x1 is equal to n1. So therefore molality, that is small m, is equal to number of moles of solute divided by mass of solvent into 1000. It is in gram. So number of moles of solute is N2 divided by mass of solvent means, you know that in the previous relation, what was the mass of solvent? The mass of solvent, if you look the previous relation, mass of solvent was x1 m1. So we will put this value in this case. Mass of solvent is x1 m1. Just a minute. Let us write it. x1 m1 multiplied by 1000. Now in place of n2 we may write x2, so it becomes x2 into 1000 divided by x1 m1. Therefore molality is equal to x2 into 1000 divided by x1 m1. So I hope you have understood this relation, how this relation is we have obtained. So molality is nothing but x2 into 1000 by x1 m1. So these are the four relations I have discussed in this video, and just in a little bit detail, uh, in gist, sorry, I have discussed already in detail. Now in a gist, this is the gist of this video. So you can see the first thing, normality is equal to molarity into nf. Nf means n factor. This is into, okay, and then molarity is equal to 10 into mass percentage into density in gram per ml divided by molecular weight of solute, that is m2. Molality is equal to capital M, that is molarity into 1000 by 1000 d minus mm2. Then molarity is equal to x2 into d into 1000 by x1 m1 by plus x2 m2. Every symbols have been the significance have been written here. And the last one, molality, that is small m, is equal to x2 into 1000 by x1 m1. So this is the video, and if you like this video, then like it, share it, subscribe it. Okay, thank you. So we'll meet in the next video. Until then, take care and goodbye.